How to find out the resultant of a concurrent force system? Let us discuss with this problem. So this is the problem statement. Find the magnitude and direction of the given coplanar concurrent forces acting at point O shown in the figure. So the given coplanar concurrent force system consists of 4 forces. Each is acting in different quadrants. Okay. So let us consider the forces one by one. First, consider the 150 Newton force acting in the first quadrant. So this force can be splitted into 2 force components. One along the horizontal direction, that is in the positive x-axis with the magnitude 150 cos 30, and the another one along the positive y-axis with the magnitude of 150 sin 30. So the horizontal force component of the first force can be denoted by Fx1, which is plus 150 cos 30 since it's passing along the positive x-axis, and Fy1, that is the vertical component of the first force, is plus 150 sin 30 since it's acting along the positive y-axis. Next, consider the second force, that is 200 Newton acting in the second quadrant. This force also can be splitted into 2 force components. One along the negative x-axis with a magnitude of 200 cos 30 and the other along the positive y-axis with a magnitude of 200 sin 30. So Fx2, that is the horizontal component of the second force, is passing through the negative x-axis, so it can be represented as minus 200 cos 30. And the vertical component of the second force Fy2 is plus 200 sin 30. Next, considering the 80 Newton force which is acting in the third quadrant. This force can be split into 2 force components, one along the negative x-axis with the magnitude of 80 cos 60 and the other along the negative y-axis with the magnitude of 80 sin 60. So Fx3, that is the horizontal component of the third force, is minus 80 cos 60 since it's acting in the negative x-axis, and the vertical component is minus 80 sin 60. Next, consider the 180 Newton force acting in the fourth quadrant. So this force can be split into 2 force components, one along the horizontal direction, that is along the positive x-axis with a magnitude of 180 cos 45, and the other one along the negative y-axis with a magnitude of 180 sin 45. So Fx4 is 180 cos 45 since it's acting along the positive x-axis, and the vertical component of the fourth force is minus 180 sin 45. Okay. So to calculate the magnitude of the resultant force, we have to calculate the summation of all the horizontal forces acting on the system and the summation of all the vertical forces acting on the system. Okay. So considering all the horizontal forces acting on the system, summation H is the horizontal component of the first force acting in the first quadrant is plus 150 cos 30, and the horizontal component of the second force acting in the second quadrant is minus 200 cos 30. The horizontal component of the third force acting in the third quadrant is minus 80 cos 60, and the horizontal component of the fourth force which is acting in the fourth quadrant is plus 180 cos 45. So by resolving this, we can get the value of summation H as 43.978 Newton. Next, to calculate the summation of all the vertical forces acting in the system. So the vertical component of the first force acting in the first quadrant is plus 150 sin 30, and the vertical component of the second force acting in the second quadrant is plus 200 sin 30. The vertical component of the third force acting in the third quadrant is minus 80 sin 60. The vertical component of the fourth force acting in the fourth quadrant is minus 180 sin 45. So on resolving this, we can get the value of summation V as minus 21.5613 Newton. So summation H value is obtained with the sign positive, and summation V value has been obtained with the sign of negative. So the resultant will be acting in the fourth quadrant. Okay. So now we can calculate the magnitude of the resultant force using the formula R is equal to root of summation HB whole square plus summation VD whole square. Already we have calculated the values of summation H and summation V. By substituting the values in this equation, we can get the value of R as 48.9791 Newton. So now we have calculated the magnitude of the resultant force of the given coplanar concurrent force system. Next, to locate this resultant force, that is, we have to calculate the direction, angular location of the resultant force. So which can be calculated using the formula alpha is equal to tan inverse of summation V by summation H. So by substituting the values of summation V and summation H, we can get the value of alpha, that is the angular location of the resultant force, as minus 26.12 degree. So usually we measure the angle with respect to the horizontal base in anti-clockwise direction. So here we have obtained the value of alpha as minus 26.12 degree. Already we have discussed about the position of the resultant force. That is, the resultant force is in the fourth quadrant. So this 26.12 degree has to be measured in clockwise direction from the reference. So we can locate the resultant force like this.